I'm Mike Huffman, Executive Director of the Cornell Institute for Climate Smart Solutions in the College of Agriculture and Life Sciences at Cornell University. This is one in a series of short presentations on climate change. This is about the basics, Climate Change 101. This is our home. It's where we live. We are tenants here. We were born here. We will die here. We need to take care of it. There's only one. There is no plan B. And we live in a very thin blanket that surrounds the planet. It's called the troposphere. In this part of the world, it's probably 5 or 6 miles high. That's it. Solar radiation comes in from above and hits the surface of the planet. Some of it is reflected. Some actually bounces back up. And some hits the surface and warms it. And you get radiant energy from soil, rocks, whatever it might be. That radiant heat then goes back into the atmosphere, and some of that encounters greenhouse gases. They absorb it, reflect it in all directions, and they act like insulation. And we've had just the right amount of greenhouse gases in the atmosphere for tens of thousands of years. But now we're continuing to put more and more greenhouse gases into that thin little blanket, and it's getting thicker, it's getting denser, and things are getting warmer because more of that radiant heat is reflected back and retained in that thin layer. One example of greenhouse gas, the most dominant one, is carbon dioxide, and you can see from approximately the year 1000 to current times there's been quite a change. It oscillated around 280 parts per million for thousands of years, hundreds of years, but more recently, the beginning of the Industrial Revolution, it took off exponentially. That's because we started to burn more fossil fuels, oil, gas, and coal. And we're currently at 406 parts per million CO2, which is about 40% higher than we should be. And if we keep going, business as usual, we'll reach 900 parts per million by the end of the century. And for the Northeast, that means 2 months during the summertime above 90 degrees. The other two primary greenhouse gases are nitrous oxide and methane. Both are more potent than carbon dioxide, but shorter lived. And climate change is caused by humans. 97 out of 100 experts in this area agree climate change is real. We are the cause. And there is a clear link between temperature and carbon dioxide concentrations. If you follow the red line, we're going back 400,000 years, and this is based on bubbles in ice core that captured the atmosphere 400,000 years ago. And you can see it oscillates from 280 down to 210, up and back and forth. But follow temperature below. It follows it very closely. So as the change in concentration of CO2 in the atmosphere changes, so does the temperature. And look to the far right, and you'll see that we're off the chart and temperatures are going to rise. Where do the greenhouse gases come from? Transportation is a big player. Over 100,000 commercial flights a day, 1.2 billion cars on the planet. Electricity production accounts for 30% of greenhouse gases. Industry, another 21%. Commercial and residential facilities, 12%, and agriculture in the U.S., these are all U.S. figures, is about 9%. So where are we? Some facts. We've already gained 1.5 degrees Fahrenheit globally. It's warming much faster at the poles than elsewhere on the planet. 2016 was the hottest year ever. Summers are getting hotter. Winters are actually warming faster than summers. The rate of warming is very fast. We gained about 8 degrees Fahrenheit since the last ice age. We will gain that in the next 100 years, if not sooner. And if we stopped everything today, stopped releasing greenhouse gases, it would still take hundreds, if not thousands of years to turn this around. And it's important to distinguish climate from weather. Weather is what's essentially happening out there today, outside today. We have 3 cold winters, 3 warm winters. It's not a trend. Climate is based on decades, comparing decades to decades, long-term trends, and the trends are in one direction. It's warming up. We do face a grand challenge. Looking to the future, if you look at the gray band along the bottom half of this graph, that represents the boundaries of the average high temperature and low temperature of a given year, starting in about 1850 to current times. They all fall within that gray band. Now follow the red line out to the year 2053. This looking into the future. That is business as usual. What it indicates is the coldest year that will be recorded after 2053 will be hotter than the hottest year we've ever seen in the last couple hundred years. We're moving into a new realm. Looking at precipitation patterns into the future towards the end of the century, You can find us in the Northeast. We'll have adequate precipitation, maybe a little more than in the past between the winter and spring. About the same in the fall. Summers will be drier, but then look to the Southwest. Mexico, where we get a lot of fruit and vegetables from, will be very dry in the spring and the winter. And the Pacific Northwest will be very dry in the summer, as well as across the plains. So changes are in the wind. There's also a 99% probability that the Southwest will encounter a mega drought. That's a 35-year drought by the end of the century. But could this be natural? No. The sun is actually in a slight cooling phase. It's not getting warmer and warming the earth. We're not getting closer to the sun because we actually circle it in somewhat of an elliptical fashion. We're also between ice ages, and experts understand El Niño and La Niña. These are natural cycles, and their impact can be to some extent separated out from what's going on, human-caused. The take-home message is climate change is real. We are the cause. It is happening fast. It will be worse if we continue business as usual, but we can tackle this challenge if we have the will. It's time for all hands on deck.